Just usage, emergency, and crisis situation. Up to you.
Thanks a lot for the presentation. And well, I'm today here to present my work about semantic visualization of Twitter user emergency and crisis situations. And the context of this work is citizen journalism. The idea is that how we can take advantage of all the information that people share every day at every moment in social media. So is to let people publish information, and information can be useful. Let's think, for example, in a big event like an election, but conference about a crisis situation or an emergency. When an emergency happens, generally people take their phones and start to share their opinion, their feeling, but also their own experience in the emergency. And in particular, not only text, but also video and photo. In literature, we have found a lot of contributions that try to understand these behaviors, citizen behaviors. So, for example, Kleinberg in 2008 speak about disinformation spread as an epidemic wave that could influence people's thinking and people's opinions. Then Alexander in 2014 focused his contribution on emergency, identify 7 different usage of social networks for emergencies, including, for example, monitoring information, monitoring crisis. If sometimes, for example, in my personal experience, it happened, the first thing I do is to take Twitter and look for some specific hashtag to follow it and have the last updates. And in 2011, Reuter introduced this idea that it's important to understand how the communication between emergency operators, emergency managers, and citizens works thanks to social media, through social media. And for example, they present several case studies, and among them the terrorist attack of 9/11, when people started to create wikis about missing people, with information about missing people. And finally, a contribution from the ISCRA MED of last year, where we present another work about the limitations that this information spread will have related to any kind of policies, privacies, or, for example, the trustability of the information. Sometimes Twitter or the social media we can find irrelevant information or false information, so it's important to be aware of it. About the visualization, there are a lot of different examples, these are just 3 of them, of visual analytics tools that allow to collect tweets and analyze them. Basically, the details, the analyzed details or the analyzed issues are related to the frequency of terms, or in order to understand which is the most discussed topics. Or, for example, the geographical distribution of tweets, or, sorry, the relation between tweets and news, official channel news. So, observing these contributions, basically they use this idea that the most discussed topics are the ones that are more frequent shared by people. We want to add something more to this idea, and we ask how can we make of all published tweets during a crisis. When we speak about make sense, the idea is to take all these tweets and extract just most relevant information. Not most frequent topics, but most relevant. So we want to focus on the semantic aspect of social media and the meaning of shared words. So our proposal is a semantic mechanism for analyzing a data set and filtering just relevant information. To do so, we propose this mechanism in 4 steps. The first step is the collection of tweets about a specific query, as for example, specific keywords or hashtags. And then first syntactic analysis for identifying from the tweets just some part of speech, and now we are going to analyze, computing the frequencies, and finally a semantic analysis where each term is analyzed in order to understand which is the meaning and compared with 7 fixed. So in order to better show the mechanism, I used this case study of the Nepal earthquake of February 2015. During the very first day of this emergency, we collect 822 tweets that this data set. Is not a complete data set of all tweets about this emergency, but it's a small one for this scope. And the search query were the words Nepal and earthquake and the hashtag Nepal earthquake. Well, first of all, we collect all the tweets, looking for the date, the geographical distribution, the retweets, and users. After that, we started with the syntactic analysis. First of all, we take each tweet and we apply a post tagger. A post tagger is a tagger that tags each word in a sentence with its part of speech. So for example, in this particular case, we recognize D as a determiner, aftershock as a noun, activity as a noun, also and so on. Verbs are verbs and so on. So the idea of this approach is to just focus on nouns, considering the particular of tweets that have this limitation of 140 characters. We posit that users use just few words for expressing their opinion because they have a limitation of space. For this reason, we decided just to focus on nouns and avoid any other part of speech. In the future, we are going to consider also the other part of speech. So once we have selected all the nouns, we obtain a first list of terms of 1,200 terms. That is too long to be accessed or studied by normal a common citizen or even an emergency manager. So we started with our analysis, first syntactic and then semantic. The first syntactic analysis is based on the frequency. There is a zip flow that states that most frequent term or term that has a too high frequency or a too less frequency are generally the less relevant ones. So thanks to this law, we reduce the list of terms to 122 terms. Among them, for example, we have earthquake with an occurrence of 326. This means that it appears 326 times in the data set. So at this point, it's fundamental to have a manual expert that reads in words and try to make sense of the selection in order to understand which is the frequency range to consider. So after that, we started with the semantic analysis, the semantic approach that is based on the computation of a similarity measure. The idea is to take all the words from the previous and compute the similarity between these words and these fixed categories. These categories has been decided thinking as a journalist asking for information about a crisis. So for example, we have the emergency, evacuation and media category in order to represent all this knowledge about the emergency description, the evacuation procedures, or the communication channels. Then we have a category hashtags with all the hashtags in the tweets, a place and time categories for representing where and when the emergency takes place, and finally a general category with all the remaining terms. In order to establish this similarity relation, we use 3 different knowledge models that help us to understand which is the meaning of each word in the context of emergency. We have to remember that in this case, a word will have a different meaning. So we have to focus just on the meaning related to the emergency domain. So in order to do so, we use these 3 knowledge models. The first one is an ontology we have developed in a previous work called semaphora. Is an abstraction and a conceptualization of different knowledge domain about emergency, evacuation, accessibility, and technology. And then, thanks to this ontology, we can understand which is the relation between different terms. So basically, we look for each term inside the ontology, and if it's found, we look to the relation among this term and the categories. The category has been chosen also because emergency evacuation media are also classes of the ontology. So in this way, we can know if a term is in relation with one of these 2 categories. If it's not found, we pass to the synonyms. So we look for the synonyms in order to understand at which level we can make this relation. And then we also use 2 taxonomy, one with countries and cities from all over the world, and one taxonomy about time expressions, in order to make the same kind of, or in order to compute the same kind of similarity with place and time. Here you can find some example of the result. For example, earthquake can be related with the emergency category, or video with the media category, and China with the place category. This step is completely automatic. So in this case, we also have some errors, but what is needed at this point is the evaluation of an emergency expert that read all the results and make sense of them. So finally, in order to present the result, we also propose a visualization. You cannot see it very well, but the idea is to put all the terms along a circle and group them depending on the category. In this way, you can see which is the most the category with a greater number of terms, and moreover, you can see which is the relation among the different terms. These relations are made based on the concurrencies of the term in the same quiz. Moreover, you can select one. This is an interactive visualization. You can select a term and see which are the other concurrencies terms. So, as you can see, one interesting result is that, well, the most great category is the general one, because we need to find a mechanism for filter in some way these kind of terms, because are general terms speaking about that people use in tweets generally. But then the second category is the emergency one, and it's something that you can understand easily, thinking that are all tweets about the Nepal earthquake. And then you can also find interesting the usage of the different hashtags and how people use this hashtag, in particular Nepal earthquake, for guiding the information flow and publish their contribution. So, at the end of this work, what we can conclude is just an additional contribution. We want just to present this additional contribution to the idea of make possible more active citizen participation in the emergencies, and not only an active participation together with the emergency organization, but the idea is to not lose this great quantity of information published on social media and make sense of them. For this, our proposal is to focus not only on syntactic information like the frequencies of the terms, but more on the meaning of the words used. For this reason, we use several data mining techniques, and we use some knowledge models such as the semaphore ontology. As semantic visualization, we use this hierarchical edge bundle. The selection of this visualization technique is related to the idea that we had few terms that are not so much, and we wanted to have a visualization that allow us to create this link and a correlation among the different terms. We are in this moment working on another case study, the case with the data set of Arik and Sandy, with more terms. And in this new case study, the problem is that we cannot use this visualization, so we are studying how to improve the visualization for more than 100 terms. So future works are working on another case study, but also evaluate the results with emergency expert to see if it can be useful for their work and it could be applied to an emergency management process. With this, thanks for your attention, and if you have questions.
Thank you very much for this very clear presentation. Are there some questions? Yes, please.
Thank you, Teresa. First of all, thank you for your presentation. My question is about the categorization process. Can we say that it's the supervised classification, I mean that the clusters or the categories are now beforehand?
No, they are automatic. The categorization is an automatic process.
But I mean that how do you know your categories before doing the classification?
No. The categories are fixed. We decide them.
So it's going to be more difficult when you deal with a big data set, a bigger data set.
Well, it depends, because considering that we want to analyze big data, the big data generation, but in a specific domain application, because the idea is to extract some useful result for emergency domain. For this reason, we decided to fix the category, to define the categories. In this way, we can guide the information to what we want. So our idea is to, okay, if people are talking about something that is not related to this category, we are not interested in it, in this approach. Okay, this is the idea.
Thank you.
Okay.
We will talk and we'll break.
Yes.
Thank you.
Just please ask a question, and discussion will be afterwards. Postpone the discussion. Question and response. Another question? Last one. Julie, you don't have a question?
Yeah. So I did just have one. I was interested in your future work, where you're going to compare different disasters, and to see if there's a common profile in the.
The idea is to not to compare different situations, but is to compare different visualization techniques. Because the idea is to understand, because we are still in process, to understand how, if changing the data set with more information, with more tweets, the visualization has to change or not. Well, then I can show you, we have a first result, and we are moving from this visualization to a bubble chart. Okay. That would be more useful in case of concerns.
And presumably the usefulness of the visualization technique depends on the audience.
Yeah, and it depends on the emergency expert. We want also to, in the same line, we want to perform a focus group in order to really understand before proceeding with the work, if they are interested or not, and what they are looking for.
Okay. Okay. Thank you. Thanks.
Okay. Thank you very much. So next presentation will be done by Umaima Naoui. This work is a cooperation between a laboratory in France, La Rochelle, and the laboratory from Tunisia, LT6, and also Malaysia. So it's an interesting cooperation, at least from a geographical point of view. The presentation will be made by Umaya. Okay, I'm waiting for you.
Good morning, everybody. I'm Umaya Green. I'm a student in research master in the business school of Tunisia. Today I'll present for you my paper with Emmanuel Bizier, Nida Daniel, et Patrice Coursier, and Semi Place. This paper names a comparative study of microblogs features effectiveness for the identification of permanent microblog users during expected disasters. This paper was signed in June 2015. It's on collaboration with the Laboratory of La Rochelle and the Laboratory of Tunisia. We begin with our plans. We begin with the short introduction, then the context of problem, state of art, approach, experimentation, and we finish with the short conclusion. To begin, we can say that the rapid development of communication technologies has offered access to rich information. These technologies, such as microblogs, have become indispensable within everyday life and have been significantly applicated in several domains, particularly. Our context is the need of emergency teams to go on the disaster-affected zones, risking their lives in order to collect information. People from surrounding areas can provide nearly real-time observation about disaster scenes by interacting in microblogs. Citizens in the effect zones can share on the field information about what they are experiencing, watching and hearing during the disaster. This information is fundamental to have an accurate insight into what is happening on the ground in order to manage emergency situations. Our problematic is a huge amount of information is shared in these microblogs during the disaster, referring mostly to irrelevant, noisy, or redundant information which is useful for emergency responders. Before we begin, we address this problem. Some works have proposed to coordinate between the human and machine intelligence in order to classify the information shared in microblogs. We find the example of Imran et al. Proposed classification model for disaster-related information extracted by analyzing tweets text container. We find also the example of Exxon et al. Proposed a gradient-boosted disaster decision tree in identified domain experts in China microblog based on profile and treating behavior features. And we have the example for Capility and all ranking users based on the features characterizing how the username is amplified via mentions, replies, or retweets by other users. And the last example for Palant all proposed a new identification model using a set of features characterizing microblog users according to the different natures of their activities and their social position in the network. To begin our approach, we study a large set of state-of-art features and some new features proposed in our prior work. The listed features may reflect the behavior and the importance about the disaster. We have split our categories in 5 broad features. The first one, profile features. The description is registered by the user himself. The second one is on-topic features. that contains a subset of a list of keywords and hashtags which are defined to describe the unexpected disaster. The third one is social network stacked features, characterizing the social position of microblog users. And we have special features characterizing the geographic position of microblog users regarding the disaster. And the last category is off-topic features. Activity refers to any activity that was not recorded as an topic one. There is an example for our features. For example, for profile features, we find certified user, enable geolocation, protected, etc. For special features, we are choose use location and share geo coordinated. And for network stacked features, we are choose number of users typically follows, etc. For features on and off topic, we are devised the categories in three subcategories: original tweets, retweets, and mentions. We collected most of the tweets shared during the UTS that have occurred from 29 to 30 September 2014 in the area situated in the south of France. Data collection was processed using our multi-agent system called Massir. The system detects the different users who have shared at least one on-topic tweets during the analyzed period. On-topic tweets are detected using the hashtags and the keywords. Hashtag keywords, encoding, hashtag mobilier, hashtag alert, hashtag inundation, hashtag red alert, which were employed by Twitter using users to share information about the disaster. For our ground truth, for the purpose of training and evaluation, users tagged in our data set have to be assigned labels indicating whether they are permanent users or no. We have asked some volunteers from our laboratory to classify the target users according to the relevance and exclusivity for the tweeters during the event. These volunteers labels each user as one of the two classes, C1 from permanent users or C2 for non-permanent users. After this study, we found that 90 users have been classified as C1 and 3,242 users have been classified as C2. To study, we study the effectiveness for the different categories with the two learning algorithms for identifying the permanent users. These two learning algorithms are SVM is used in order to learn a linear model for the identification of microblog permanent users. In order to deal with the unbalanced data classification problem, we gave a more important weight to the class 1 of permanent users. The second learning algorithm is artificial neural network, who use it in order to train and test multi-layer classification model by experimenting several combinations of feature categories representative to microblog users. As there is not parameters to tune the class weights using ANN, we have duplicated the dataset of permanent users by 30 in order to balance the two datasets of permanent and non-permanent users in the training phase of ANN. For experimental setup, we randomly sampled 60% of both prominent and no prominent labeled users dataset as obtaining data for learning the classification and ranking models based on different features, and the remaining 40% as test data to test the efficiency of the learning model. For the first phase, the training phase, we find that 54 users are prominent. But for the test phase, we find that the number of prominent users is equal to 36. Through the different experiments conduct to evaluate the efficiency of the different feature categories for the classification of microblogs. We have used standard precision, Likert, and F1 scores evaluation methods. In order to select the most representative feature categories for microblog prominent users in a disaster, we evaluate the effectiveness of each category of the state-of-the-art features separately. The table reports the experimental results evaluating the effectiveness of each category of features. We note that ONAF is the most representative category for a prominent user in a disaster context, but the remaining categories of features have yielded poor results and failed to identify microblog prominent users. In this table, we study the effectiveness of these categories when they are combined with the feature categories. We observe that they have a negative effect when they are combined with ONAF categories. And we note that the combination of features on ONAF improves the identification results using both ANN and the SVM. In this table, we select the most efficient combination ONAF plus OFF in order to enrich with the remaining categories of features. There is not a significant enhancement when adding a third category of features to ONAF and OFF. Only the special category of features slightly improves the identification results obtained by learning the SVM model. In this table, we note that combining the four categories of features ONAF, OFF, and the SPF reported have failed to improve prominent users' identification effectiveness. For our discussion, we can have to conclude on the report using the on and the off topical activities features categories. The special features category to learn an efficient classification SVM model identifying prominent microblog users during real-time disasters. And we find that off-topical features are extremely useful where prominent users mainly in sharing disaster-related information. We show that users geolocated in the disaster are more susceptible to share flash and relevant information about what is happening around them. Then you can see that the on and the of features are almost the only categories that can differentiate microblog prominent user from non-prominent one in a disaster context. We can also that we noted that the SVM algorithm is more prominent user when it is learned based on the special on and off topic features. is evidence.
Okay.
For this presentation. Are there some questions?
Special features are, I think, a bit underused because geolocation in Twitter is only turned on by something like 1%. So perhaps could you also use the content of the tweet as a special features? I think about name of cities, name of places. And have you tried to investigate using the content of the tweet as a special feature?
We say that we are choose the name of cities and geolocation.
Yeah, but you are using geolocation in the tweet and special features in the profile of the users, but perhaps not in the content of the tweets? Or do I miss something?
Maybe, but for profile we can find if you know her application, but not messages and information for geolocation. I think that the categories are classed in a good you speak in French? En fait, nous allons bien classer les caractéristiques selon leur proportionnel. Ça veut dire pour le profil, on trouve les choses que l'utilisateur fait. Mais par exemple, pour les géolocalisations et tout, il vaut mieux qu'on les met à part parce qu'il y a des informations exactes qu'il faut le mettre à part.
Okay, is there another question, please? Okay, you mentioned, and please give the response in English because some of the participants do not understand French, even with your words. You mentioned Massir as a multi-agent system, able to research in the blog, microblog. So could you give us some precision about this system?
Yes, this system is prepared by my professor in MBC. We prepared our keywords like enterprise, like area, etc. And we research this name in the tweets, and we prepared a short application to, for example, to find this word, or to find the number of the iterative to this word, etc.
Okay, thank you. We have to congratulate her because she's a master's degree and she good work. Good job. Okay, thank you. So there is a permutation for the next presentation. We will, yes, well, ready. We'll present first. This is a work with Nesrine Daniariel, Narges Benamini. the type of intelligent application of large scale to support collaboration during emergency management. Try to, as possible, to face the public and not to.
So good morning to everyone. I'm a user and a member in the laboratory in the National School of Computer Science. Today, to speak about an intelligent application of large-scale community detection to support collaboration during emergency management. So the outline of this presentation is as follows. Firstly, I'm going to present the main purpose and motivation of our paper. In section 2, I will speak of related works using social media in emergency management. Then I will describe the proposed approach. In section 4, I will present experimentation and results, and I will finish off with conclusion and ongoing work. So the first question we have to ask is why we need this application? The answer will be the content of the first section. Unhappily, on the last April, a storm hit Nepal. With damage on building and thousands of deaths and injuries. Following the disaster, many people used social media for help and to find new collaborators for emergency management by creating, for example, group page or sharing picture. However, finding rapidly the most relevant collaborators is so these people involved in disaster is to provide for them an intelligent application which aims to recommend the relevant community. Then, before showing the proposed approach, let's see some related works using social media in emergency management. When we say social media, it means internet-based applications that enable people to communicate and share results and information, such as in Facebook and Twitter. So, due to the popularity of social media, several research use it in emergency management. For example, Temnikova presents an extensive terminological resource for crisis management in English. As for Nagi, use microblogs to detect the sentiment of the crowd towards crisis or disaster. Also, social media can be used in on community detection. For example, Misewi detects cluster during emergency in order to analyze the behavior of Twitter users. So, inspiring from this solution, using social media to analyze and understand the behavior of citizens. The aim of this paper is to show how media can be effectively used to engage collaboration during emergency response and how generic community detection can be specialized for emergency management. Now let's see the proposed approach. The intelligent application of recommendation is based on 4 phases. The first phase is data preparation. data preparation. This phase aims to collect and extract information about users. Then, this data will be presented by a graph. This graph will be the input of community detection algorithm. Finally, we propose to evaluate the detected community in order to improve the community detection. This phase will be based on the user tracking. In this paper, we focus on community detection, the third phase. Why? Because the quality of detected community depends on the choice of community detection algorithm. So, in this paper, we choose to use a new algorithm for collaboration recommendation. This algorithm is based on two approaches. The first approach is modularity of Newman, which considers only social connection, and automatic classification based on inertia, which concerns the attribute similarity. This approach aims to bring together individuals with the same features. So, we say that this algorithm combines two approaches into one approach by proposing a new combined metric. This metric must be maximized to obtain the relevant community. However, this problem is hard, so this algorithm relies on a computational technique for NP-hard optimization, which is particular swarm optimization. So to resume now, when a Facebook user is seeking for help for emergency management, this application identifies the object and the context of his search. Then it extracts information and collects user profile involved in this context. These data are represented by a graph. Each node represents a user profile, and each edge represents friendship between two users. Then this graph will be the input of community detection algorithm to recommend relevant collaborators for this user. And finally, it evaluates the detected community. For experimentation, to evaluate our approach, we choose to compare its results with Louvain algorithm, which is based on network structure by optimizing modularity. This algorithm is experimented and has been successfully tested on different benchmarks. So we apply the two approaches on Facebook networks. To do use profile and networks data obtained by ISCRA MED. Every node so represent a Facebook user with these static features such as age, education, and dynamic features such as Facebook status. And here edges represent friendship between users. We add to the social network so a context, which is here citizens of Nepal who is seeking for a doctor for this. And at each step of experimentation, we increase the size of the network and we apply both approaches. As a result, this experimentation has shown that our approach is faster than Louvain approach. and concerning the quality of the gives better results. In this, to conclude, in this article, our aim is to propose architecture of an intelligent application that support emergency management by recommending relevant collaborators. This intelligent application is based on a new community detection algorithm that combines network structure and profile homophily or similarities. In future work, we hope to complete the development of this intelligent application by making data preparation and evaluation automatic. And we propose to use this application on other social media and other scenarios to support collaboration recommendation. And thank you for your attention.
Okay, thank you for this clear presentation. Are there any questions? Yes?
Thank you. My question is about the evaluation step. I mean, how do you know that each user was assigned to the right community?
For the evaluation. So our application aims to identify the most relevant community. Not detected the all communities for all users.
How do you know that your algorithm gives you the best?
For the evaluation,
Yeah.
we want to make the evaluation step really based on user tagging.
Another question? Not hesitate. What do you mean by that?
Because it is able to specify the context of the search
The co-author, Nasreen.
There is a quarter that could help, possibly, why not?
The supervisor.
I'm Ms. Yahya, I'm a co-author on this paper. Donc, just for the question number one, for the evaluation, at this moment, the approach is based on some things. Okay, but on this paper, she's worked on the third phase for the community detection. For the evaluation network, she will try to identify the different metrics and the relevant metrics for our needs. And for the intelligence, the approach is intelligent because it's based on different techniques of artificial intelligence, such as the vertical swarm optimization and the community detection. It's also a technique from the intelligence artificial intelligence.
Okay. Another question, you mentioned the work of Louvain, yes? But you know, at Toulouse, at Frédéric Amblard, Rémi Cazadet made work for detecting big communities. How do you position your work regarding this one?
I think we must try to apply this different algorithm and approach on different benchmarks for the for
for this works, he didn't work on social with social media. The input, the difference is the input of the algorithm. Here the input is a real network and social.
It's not a problem. I do not completely agree. We will discuss about that, but it's not. It was just to animate it. Thank you very much. So, last presentation will be done by Iman Hamid. And the presentation is about recognizing information spreaders in terrorist network, etc. And so the work is a cooperation between Tunisia and the CNAM of Paris, Labo Cédric. So two papers were based on collaboration between France and Tunisia. That is a good point. To the left.
We know this was not. Yeah.
Thank you, and sorry for So, my name is Iman Hamid, and today's presentation is about a very complex, yet very widespread phenomenon. It's about terrorism and how can science can prevent or at least decrease this phenomenon. So today we can to recognize information spreaders in terrorist network. Along this presentation, all the following outline. First, we introduce the general context of our approach, and after that, we will expose different literature work. Then we introduce our approach, and then we discuss and interpret the simulation results. And after, finally, we conclude and open up new possibilities for further research in this field. Okay, so networks are ubiquitous in our world today. Take the example of the communication networks or contact networks, which change the way we are dealing and interacting with each other. So the study of network becomes an essential issue. Basically, network is composed of some actors or nodes, which can be individuals, organizations, or even events, and the relations between those actors, which are the connections between the different nodes in the graph. To get a deeper insight about these networks, social network analysis is a set of relational methods to understand these networks. Among the aspect analysis of social networks, identifying the most central node in the network becomes an essential issue, and this can be done by computing centrality metrics. So what's a centrality? A centrality is a logic measure. It's a mathematical formula computed to recognize or identify important node or central node in the network. Some examples of centrality: betweenness centrality, age vector, and closeness. So betweenness measures the capacity of a node to maximize the information flow between other nodes in a graph. The age vector centrality measures the average shortest path between nodes and different other nodes. The closeness centrality identifies the influence of a node on other nodes. Social network analysis has been included in different domains, like the study of epidemics, and like the investigation services, which is a whole domain called IDM, or investigative data mining, which is a set of social network analysis methods and techniques to counter terrorism. Well, terrorism has been really very widespread around the world, and it's multiplying and increasing on the last years, and especially recently witnessed the terror attacks in our country appeal for an urgent review. Using social network analysis, different work emerges to destabilize the terrorist networks. The destabilization of terrorist networks means the isolation of important nodes responsible for the terror incident. Some examples of the works of the destabilization approaches in the literature. Some authors use the degree between age vector and closeness centrality, and other ones use the cut and bit rank centralities to reveal the hierarchy of the terrorist network and then reveal the most important node in the network. While those approaches were proposing to identify the most central node in the network, actually the best node to attack is not always that which has the most patients, and the most central node is not the leader of the. It can be a finance manager, for example, or a gatekeeper, or any other role. So we propose to detect or recognize the information spreaders in the terrorist networks. We believe that those nodes or those actors are of important danger, and if we
if we can destabilize this network, recognizing these hijackers. To do so, we propose to compute the percolation centrality for different nodes. So the percolation process starts well, it's a dynamic process. Starts when a node gets, and then it percolates nodes which has. So the state of node B alters the node A alters the state of B at t equal to 2. So the node B becomes also percolated. Formally, the percolation centrality adopts the logic of betweenness centrality since it relies on shortest path, but it also it is also based on the state of a node, which means that the state is fully percolated or partially percolated. In our context, we consider a binary percolation state, which means a node has received or not received a piece of information. There are two extreme cases with the percolation centrality. When one node is percolated over the whole network, the percolation centrality reduces to the betweenness centrality. If we compute the percolation centrality of all the nodes over all the nodes of the graph, we find that the percolation centrality is trivially equal to the betweenness centrality. Also, another extreme case is when all the nodes on the graph are percolated, so the percolation centrality also reduces the betweenness centrality, because the sum of the percolated nodes is equal on 1 averaged n minus 1. As a case study, we choose the network of hijackers involved in the 26 November 2008. It was an attack in India. The network consists of 13 nodes. 3 among the 13 terrorists were handling the operation from Pakistan, and the other nodes were dispersed in different regions in India. We start the percolation computation. First, as we have said, at t equal to 1, the percolation centrality is trivially equal to the betweenness centrality, so we have computed the betweenness centrality on nodes. Node number 2 has the highest betweenness centrality. 14 nodes in the graph equal to, and then at t equal to 2, the percolation centrality. For sake of clarity, we have divided our nodes into peripheral nodes and non-peripheral nodes. Of course, peripheral nodes are the nodes on the edge of the graph, like node number 5, 6, 12, 13, 8, 9, and 10, and 11. No peripheral nodes are the nodes in the center, like in node number 4, 7, 2, 1, and 3. So as you can see, or as you can notice, that the peripheral nodes percolation holds a higher percolation centrality, especially for nodes number 8 and 9, 5 and 6 also. Peripheral nodes less percolation centrality than the peripheral nodes. People think peripheral nodes holds a higher percolation centrality than non-peripheral nodes. And node number 8 and 9 shows a high percolation centrality and compared to the other nodes. At t equal to 4, nodes number 8 and 9 lose their importance in the percolation process, and node number 5 and 6 starts to shows a high percolation state. So we may conclude that nodes number 8, 9, 5 information stored in the report given by the Indian government. But nodes number 5, 6, 8, and 9 were exchanging information with the 3 universities in Pakistan. So we have conducted dynamic analysis of the 26, and we have most of the questions in the study. As a future research, we study the percolation centrality in large scale then because the network that we have considered network and is static, and we aim also to look for disruption strategy with combining the percolation centrality metric with other metrics. Thank you for your attention.
Presentation on the
network. And seeing, okay, well, this is the node that is responsible for that different time, then that would change. Is it count in any way in your approach?
Sometimes steps, the same information spreaders, this is over process. However, sometimes certain
Yes, there is another question here. And François after.
On the answer in the bit.
Hello. Thank you for your presentation. There is a tricky question maybe.
yes.
Because one of the problems with this kind of approach is what happens if you say someone is information center and it's maybe not the case. Depending on the country where this is happening, the consequences can be dire. So my question is, how you show the graph here, 3 people,
Yes.
3 nodes,
Yes.
over how many nodes?
13 nodes. 3 among them were in the operation from Pakistan. They were not present in the terror incident.
Okay, so 3 over 13.
Yes.
So 25%?
13.
Yeah. I was thinking about the percentage, meaning just picking 3 people by chance.
No, it's not by chance.
No, I know it's not by chance, but I want to compare the results, picking people by chance and your method. It's a bit tricky. I told you first. So, can you provide? It's the same question which was asked before about the categorization. That you are not mistaken. You can ask them, but it's not practical. But how do you check that? How do you, because and close down with the first presentation with a huge responsibility, showing that this guy, and oops, sorry, my bad. It was a method, not me, not personal. So it's a very interesting question because a lot of information, and a lot of political consequences that could play. So have you, from a specific point of view only, have you any indicators which may say I've got 80% of chance compared to what would be the result if I were just taking by chance? You want me to rephrase that? Indicators with fiability. Saying, for example, I am sure about 75% that there's something going on there.
Thank you. I'm the co-author of this paper, so it's a very good question. the evaluation step, in fact. Actually, we are still working on that, on the evaluation. We need to have some metrics to evaluate the results. But what we can say that this approach is now useful after the event. But
It's always nice.
yeah, it's just to be sure that people who were involved in this attack are the right persons, but to predict.
No, it's not about prediction. But what I understood wasn't the people who were attacking. It was the people who were somehow supporting the attack by propaganda, I guess.
They were spreading the information in the network. Yeah. So I think we should work on the evaluation to be sure that this approach gives good results.
So, I may not have understood, but you said that you have checked with the India government saying, hey, I got 3 names. What do you think about that? And they say, hey, good one. Was it what happened?
In fact,
Good luck.
okay, the report given by the Indian government reveals that those notes, which have been revealed by my approach, were exchanging information with the 3 handlers in Pakistan.
So it's information you
Yes,
went after.
information by cell phone, telephonic conversations. Okay. Thank you.
Okay, just,
Yeah.
yeah, so I still have my question because it was not fully clear for me, but the data you have are, it's a network of conversation, right? Or it's not,
And I was right the network.
yeah, but it's not a social network or Facebook
Yes,
or,
yes,
it's just a mobile phone calling each other and their metadata.
yes.
Because these are data that are not easy to
Yes. Confidential,
some
yes.
people they can get them. Thank you.
Question there.
My question is,
Yes.
my question is about the characteristics of the terrorist network. I mean, is this approach only valid for such networks, or can you consider it as useful each time? Will be interested by finding information spreaders in a network.
Okay. Information spreader is just an example. You can use this approach for studying epidemics, for example. The propagation of a virus, for example, or you can use it in different approaches, not only on the terrorism.
Marketing.
Yeah, rumors.
Lot of money.
Rumors.
Yes.
Actually, and that could be one thing that you could look into for the evaluation of your approach. Apply it to a different network where people are happy to give you information, rather than having a network where you're trying to, of terrorists.
Yes,
You know, people are not like, yes. So you did it on another application that would help to evaluate work.
Of course, it's a future step.
I just have a remark regarding the keynote of this morning. Be careful not to put your program on the hand of decision makers, because they will say yes or no. They will not consider that as a complex situation. So be careful. Are there other questions, even about the previous presentation? For example, the first presentation, I thought you were late, has only 2 questions. You can ask other questions if you want, even for the other presentation. remarks? Yes?
I think that unpredictability is one of the most problems that we have to deal with in these research works. So can you explain deeper how do you deal with the unexpectability of such events or an unpredictability of such information diffusion in the considered networks?
Actually, I do not really, I do not take really in this approach very much, just the beginning. And of course, I will see this in other future steps.
If the other speakers would like to answer this kind of question, how do you take unpredictability in your solution? You are free to give your point of view. No? Yes.
Well, in my case, it's not because we don't consider it because basically all the information collected is searched by some keywords. So it's in this case we control in some way the information flow. So we are sure that are related to some topics, and then thanks to the semantic analysis we confirm and guarantee this result.
Maybe people are using wrong. Maybe people are using the wrong hashtag.
Well,
This is insecurity.
no, it's the case because we take some strange word in the yeah, but we try to avoid this kind of misunderstanding with the semantic analysis. So checking for the meanings and relating them with the different categories. But yeah, people publish different kind of content with the wrong hashtag sometimes. And I think that it's all for both. Yeah.
Other remarks, questions? Do not hesitate.
My question is about the application of your approach. It's about the number of nodes, minimum number of nodes to be can apply this approach, and the user that yes, the minimum number of nodes to can be applied this approach.
Minimum numbers.
On the size of your network, it is a small or big?
Yes, a very tiny network, 13 nodes. We aim to consider larger networks of hundreds or thousands of nodes.
About quality. The data, the collected data.
Yes, it's an adjacency metrics that are transferable to network.
Okay. Question?
Thank you.
I have just an information.
Yes, just practical information from. So we can go to have the take on lunch from the reception.
Yes, that's from the desk.
From the desk, the registration desk.
And we will go to the restaurant to be indicated, and we will have 1 hour and a half break for lunch, and be back later.
Please, for the next session, the person who have to present be at least 10 minutes before to prepare. Something uncertain. One is possible. Okay. Yes.